subhanahu wa ta'ala for all his blessings and bounties that he has bestowed upon us. فَبِأَيِّ آلَاءِ رَبِّكُمَا تُكَذِّبَانِ. We need to make shukr to Allah subhanahu wa ta'ala, who has made us as mankind the best of all the creations. The creations of Allah subhanahu wa ta'ala that we can see, the creations of Allah subhanahu wa ta'ala that we can't see, and even those creations of Allah subhanahu wa ta'ala we can't comprehend about them. Yet Allah subhanahu wa ta'ala has given this mankind the best of all the creation, the ashraful makhlukat. On top of that, He has created us in the Imam Muhammad sallallahu alayhi wa sallam. The best of all the Anbiya alayhim Islam, they came to existence from Adam alayhi Islam till the last messenger Muhammad sallallahu alayhi wa sallam to guide the humanity so that each and every mankind could be successful not only in this life but the life hereafter. Those people who said labbaik to the voice of the Anbiya alayhim Islam of their time, Allah subhanahu wa ta'ala made them the most successful people. On the other hand side, those people who denied the voice of Anbiya alayhim Islam of that time, Allah subhanahu wa ta'ala made them the most unsuccessful people. If we look into the life of Shaddad, Firaun, Namrud, despite their might, despite their wealth, despite their kingdom, Allah subhanahu wa ta'ala made them the most unsuccessful people. On the other hand side, if we look into the life of one of the companion of the Prophet sallallahu alaihi wasallam, like Hazrat Bilal Habshi radhiyallahu ta'ala anhu, had no status, no worldly status, no race, dark in complexion, yet Allah subhanahu wa ta'ala has elevated his status so that he is going to be the very first person to enter into the paradise. So in order to get the real success of this life and the life hereafter, we need to follow the commandments of Allah subhanahu wa ta'ala, the way shown by the Prophet sallallahu alaihi wasallam. So inshallah, learning, talking and propagating it will be very, very beneficial for all of us. Today is 14th of December 2020 and we are continue with infinite sequences and series. If you remember from the previous lectures, we got an idea about sequence. Sequence is going to be pretty systematical arrangement. And when we look into the convergence or divergence, we see that the nth term of the sequence is the most vital term, because the convergence or divergence of the whole sequence is based upon the convergence or divergence of that particular nth term. Then we move on to series. Series is going to be the combination of the terms of a sequence. So again, the foundation arrangement is there, systematical arrangement. Now we are going to combine them as one unit. So in order to see the convergence or divergence of a series, we generally look into the nth partial sum. And then based upon the convergence or divergence of the nth partial sum, we describe the series to be convergent or divergent. Alternatively, we say that geometric series with common ratio less than 1 is to be convergent, otherwise divergent. Then we will be having a P series, hyperharmonic series. So based upon the value of P, if P is greater than 1, we say that the series is going to be convergent, otherwise it is going to be divergent. Nth term divergence test is another alternative option. Based upon the limiting value to the nth term, we see the divergence. And one more option is the integral test. So based upon the convergence or divergence of the corresponding integral, we look into the convergence or divergence of the given series. So these are the prominent options that we have discussed so far. Now we move on to look into one of the option other than the previous to see the convergence or divergence of a given series, known as comparison test. So comparison means sometime if you are interested to see the convergence or divergence of the given series, it is going to be a bit difficult sometime. So what we do, in this case, we will make a comparison with the one whose convergence or divergence is known. And based upon that comparison, we will describe the convergence or divergence of the given series. So this is all. We will look into the comparison test. If you look into the description, previously we have seen that the convergence and divergence of geometric series, P series, and some other options are there, like integral test, like the nth term divergence test. Now we move forward to observe the convergence or divergence of many other series by comparing their terms to those of a series whose convergence or divergence is known. And based upon that known result, we will describe the convergence or divergence of the given series. For example, we have 3 series are there with nth term to the first one, AN, PN, and CN respectively. So we have been given this one, the one with nth term AN. So we are interested to see the convergence or divergence of this series with the condition that AN is going to be greater than or equal to CN, and which is further less than or equal to BN. BN is the nth term to that series, CN is going to be of this series. So we are interested to see the convergence or divergence of that series. Now, based upon some comparison, we will look into the convergence or divergence of the given series. So 3 series are there. So we are interested to see the convergence or divergence of AN. This test shows that if BN converges, then AN converges. So BN is going to be a bigger element. For all sort of values of n, Bn is going to be greater than or equal to An. So if that component is going to be convergent, we say that, okay, the series with nth term An is to be convergent. We do not look into the convergence or divergence of this one directly. Rather, we come round the way. If that one is convergent, So the one with nth term an is going to be convergent. To the other end, if the series with nth term Cn is divergent, what is Cn? For all sort of values of n, Cn is going to be less than or equal to an. If the series with nth term Cn is divergent, then based upon that divergence, we say that the series with nth term an is going to be divergent. So this is all. We make a comparison. Directly, we know the convergence or divergence of Bn and Cn respectively. And based upon the convergence or divergence of Bn and Cn, we say that the given series is going to be convergent or divergent. So this is the comparison test, or sometimes also known as basic comparison test. But before we move on, we just look into the basic elements to be discussed. Now keep an eye. You must have the handouts with you people. So keep an eye. When do we say that the given series is convergent? Based upon the convergence of Bn, why do we say that? And when do we say that it is going to be divergent? Based upon the divergence of Cn. So we try to figure out why do we say like that. So we go on the sideways board. I try to demonstrate that what are the options behind the scene. The most prominent thing, remember, you need to recall from the previous lecture, is to look into the convergence or divergence of the P series. Very powerful result is it. Within a fraction of a second, you can look into the convergence or divergence of a special type of series with specific nth term over there. So have a look. So we know that that one is going to be the P series n raised to power p. So n varies from 1 to infinity. Positive integral values or natural number is there. We say that it is going to be convergent or divergent based upon the values of p. So this is how we say that it is going to be P series. So based upon the value of P, this particular series is to be convergent if P is greater than 1 and is to be divergent if P is less than or equal to 1. So pretty simple idea is it. I just look into the value of P and directly we say the convergence or divergence of this P series. So very elegant, a very compact form of a particular series to describe the convergence or divergence. So keep an eye, this very powerful result, the convergence or divergence of a P series. I mean, just take an example. If P is equal to 2, for example, you have a series with nth term as 1 upon n square. Since P is going to be greater than 1, so directly we say that the corresponding series is going to be convergent. Nothing to do behind the scene. Now, what the convergence, what the comparison test is there effectively. So have a look. We try to figure out the convergence of the given series. We are interested to see the convergence or divergence of a series with nth term is an. But we will try to figure out the convergence or divergence of Bn and Cn. Based upon that, we will look into the convergence or divergence. So we are interested to see the convergence or divergence of a series with nth term to be an. But directly, things are more complicated. We will not look into that. Rather, alternatively, we come around the way. We will look into the convergence of this one and divergence of that one. So why and how do we see that? Just imagine behind the scene. To take a simple example, we say that Cn is going to be that. The total area contained by Cn is going to be that one, for example. And here you go with An, a bigger part. The total area for, so this is the total area, for example, for Cn. And here you go with An. An is going to be bigger element in comparison of Cn. That does contain Cn as an element. So Cn is going to be contained inside An. So we say that if that one is divergent, no, convergence or divergence, simply in the loose term, we say that if the limiting value to the nth term is finite real value, we say that it is going to be convergent, otherwise it will be divergent. So we say that if the answer as a limiting value to the nth term of a series labeled as Cn is divergent, then surely that series with nth term An is to be divergent. Why so? I mean, in the loose term, if you imagine the answer to this one is infinity, then you add something into infinity, it will remain infinity. So if that component diverges, we say that the bigger one, which does contain Cn as an element of it, essential element of it, is also going to be divergent. Now take another one. For example, here you go with Bn. Bn is even larger than An. I mean, this is all we have the relation between them. Cn is there, Bn, and then finally An is there. We are interested to see convergence or divergence of An. So Cn is the smallest component, and the largest component is to be Bn. So the total area, for example, for Bn is going to be that one. That does contain An, obviously does contain Cn because Cn is going to be an element of An. So now we see that if the answer, if that one is convergent, if Bn converges to a finite real value, so surely An to be convergent. I mean, if the answer to Bn, if you look into the limiting value to Bn, if the answer is going to be a finite real value, so the one which does contain inside that one will be having finite limiting value. So this is how we make a comparison. The converse may not be true, remember? The converse, I mean, if you come around the way and say Cn is convergent, we can't say anything about the convergence of An because might be the troublemaking point is there, the troublemaking value is over there, troublemaking value is over there. That part is going to have a finite limiting value, but the one which is outside that one, for example, over there, we are not sure. So the converse may not be true. We have only one-way traffic. If Cn divergent, An is to be divergent. I mean, for example, if the answer to Cn is infinity, and that one which does contain infinity, so infinity plus something finite is going to be infinity. On the other hand side, Bn is going to be the biggest component. The total area, for example, that one does contain AN. Now we are going to talk about the comparison between AN and BN. So if the answer is finite real value to Bn, then surely with this comparison, because An does contain inside Bn, so the answer to An is surely finite real value. So this is how we look into the comparison test. We will try to figure out either Cn or Bn, and based upon the convergence or divergence, we will say convergence or divergence of AN. So conclusive remarks are there. So we are interested to see the convergence or divergence of AN. So if Cn with another term divergent, so does AN. If Bn converges, so does AN. So we are interested to see the convergence or divergence of AN. So it all based upon the convergence of Bn, which is going to be the largest component, and it will be divergent if that is with another term Cn is divergent. So this is how we will look into the convergence or divergence of AN by using basic comparison test. Based upon that comparison, we will figure out the convergence or divergence of the given series. We take a few examples from the exercise. Have a look at exercise number 10.4. First bunch of questions from 1 to 8. Use the comparison test to determine if each series converges or diverges. So we are interested to see the convergence or divergence of this series. So by making a comparison, you need to look into the series, the one which is going to be compared with that one, and then based upon the convergence or divergence of that known series, we will directly say the convergence or divergence of this series. Another element is there. They are all non-negative term series, AN, BN. I mean, if you look into the comparison of AN and BN, so both are non-negative terms. Or if you make a comparison between Cn and An, again, they should be non-negative terms. So this is one of the criterion that you need to fulfill before you look into the implementation. So the one which is to be selected for the comparison with that series should have non-negative terms. So you can see that clearly. Every term is going to be non-negative from here, whatever the value that you choose from 1 to infinity. So you have to compare with the series that should also be with non-negative terms. So how do you select the other term? There are more than one options. Sometimes things are more complicated. You cannot look into the way. You need to make your mind yourself for certain special cases. But generally, it's pretty simple to observe the comparison. What the idea is there behind the scene? How do you look into BN? Because you need to take the one which is going to be greater than or smaller than that one. So we have been given this series. We take into consideration example number 1. So series is there with nth term 1 upon n square plus 30. So keep an eye on this one. So we are interested to see the convergence or divergence of this series. So idea is there. We will take into consideration the second series. How do you observe the nth term of the second series? From that nth term. Take the highest term from the numerator, take the highest term from the denominator. And this is how you will choose the second term, second series with nth term. So again, take the highest term from the numerator, and then the highest term from the denominator. What the highest term from the numerator? It's n raised to power 0, and the denominator it's n square. So this is how you will choose a series with the nth term to be 1 upon n square. You will compare with that one. First of all, you need to justify whether it is Bn 1 upon n square or 1 upon n square with the nth term 1 upon n square is to be Cn. And then based upon the convergence or divergence, you will look into the convergence or divergence of that given series. So take a note before we move on to the sideways board. We have been given the series with nth term to be 1 upon n square plus 30. So try to figure out. So we need to figure out the convergence or divergence of this series. So what we do, we are going to compare this series with the one with nth term to be obtained from here. So this is going to be the nth term of the given series. So what we do, we will compare with the series with nth term to be something like, take the highest degree term from the numerator, it is going to be n raised to power 0, or in other words, it is going to be 1. And take the highest degree term from the denominator, it is going to be n square. So we are going to compare the given series with nth term 1 upon n square plus 30 with that one. How do you observe the other series from the nth term of the given series? Take the highest degree term from the numerator, take the highest degree from the denominator. So this series is to be compared with that one. What type of the series is this one? So it's a p-type series, you see that? 1 upon n raised to power p. What is p here? P is equal to 2, which is greater than 1. And surely we say that it is going to be convergent. A p series is to be convergent if p is greater than 1. As we see in this case, p is greater than 1. Effectively, the value is going to be 2. So this series is convergent. The one which is going to be compared with that one is a convergent series. And on both of that, on top of that, both series are of non-negative terms. Both series are of non-negative term series. So we can look into the implementation of the comparison test now. So first of all, you justify how do you observe the one which is going to be compared. Secondly, you need to look into that criteria that both series should be of non-negative terms. every term should be non-negative. All right, so now I look into the solution. Note down the wording. Compare the given series. Compare the given series with that one. And this term to be 1 upon n square. Compare the given series with that one, which is a convergent P series, which is a convergent P series as P is equal to 2 is greater than 1. So why do we say that it's a convergent P series? Because P is equal to 2. That is greater than 1. Full stop. Both series are non-negative term series. Both series are non-negative term series. And n square plus 30 is going to be greater than or equal to n square. Surely we will be having this inequality for all sort of values of it. For all sort of values of n, we say that n square plus 30 should be greater than or equal to n square. I mean, we look into that one. So now you need to make a comparison in a way that you need to justify, is it going to be Bn or Cn in comparison of that An? So how will we justify that? If you look into the article, there was something like An is to be less than or equal to Bn, and that is going to be greater than or equal to Cn. So you need to figure out whether that one is going to be Bn or Cn. So we look into that. So take n square from there, n square plus 30 over there. No, if you invert it, invert both sides, n square plus 30. So surely the inequality is going to be changed. Inverting both sides means 1 upon n square plus 30 is going to be less than or equal to 1 upon n square. Now you can figure out, you see that one is going to be Bn, and there you go, An. So we look into the comparison of that one. An and Bn. The one which is going to be compared with a given series with nth term to be 1 upon n square plus 30 is going to be less than or equal to the corresponding nth term of the other series. And that one is basically Bn because it is going to be greater than or equal to the nth term of An. So initially, we have seen that the series is going to be convergent because it's a p-type series with p greater than 1. And now we also have shown that Bn is going to be the largest component. And if Bn converges, surely n converges. So finally, hence, by the comparison test, the given series is a convergent series. Hence, by the comparison test, the given series is a convergent series. So this is how we look into the convergence of the given series by comparing it with the one which is going to be of this particular form, means the nth term is going to be greater than or equal to the nth term of the given series. We directly can't say anything about that one. Rather, we look into the convergence of this one, and based upon the comparison, we say that the given series is going to be convergent. So only technical part is to figure out the second series. The rest of the part you need to make a fair comparison between them. Either the other one is going to be labeled as BN or CN. I mean, this is all. We have the description of the comparison test. I mean, if CN diverges, AN diverges. If BN converges, AN converges. So first of all, figure out the second series based upon the given series, and then make a relation between them. Means you need to decide whether the second series which you have obtained from the nth term of the given series is to be labeled as BN or CN, and then you justify the convergence or divergence of the given series. Take a few more examples to illustrate this concept. For example, the second one, n minus 1 upon n raised to power 4 plus 2 is there. So again, what is the criterion? Take the highest degree term from the numerator, that is going to be n raised to power 1. Take the highest degree from the denominator, n raised to power 4. So n upon n raised to power 4 resultant 1 upon n raised to power 3. So this is how you need to compare this series with the one with nth term to be 1 upon n raised to power 3. And we know that 1 upon n raised to power 3 is going to be a convergent series. It's a p series with p greater than 1. Only second component of the solution is to relate this nth term with bn. If you look into this one, so you can easily look into the second series 1 upon n raised to power 1 by 2. So over here it would be 1 upon n. And sometimes things are more complicated. You see that hardly you can have the criterion over there. It's pretty simple. If you have polynomial over there, the fraction between two different polynomials, so much easier to take the second series. But if there are different cases like number 6 or number 5, you could have more than one options over there. Like in number 5, you can take 1 upon n raised to power 3 by 2 to be compared with that one. Over here, you can have the option of like 3 raised to power n. If you take 1 upon 3 raised to power n, so it will be a geometric series, I believe. So n raised to power 1, then n raised to power 2, 9, 27, and then so on. It will be geometric series. Or you can compare it with 1 upon n. So p series with p is equal to 1, divergent. So anyway, you can have more than one options. You have to make your own mind for certain cases. Generally, it's true. Like in this case, for example, take the highest degree term, it is going to be n from the numerator, square root is there, of course. And from the denominator, it is n raised to power 4. So the one which is going to be compared with that one will be having nth term as, under that radical sign, 1 upon n raised to power 3. So in other words, 1 upon n raised to power 3 by 2. You need to compare with that one. So this is all based upon the convergence or divergence of the compared series with the given series. We look into the convergence or divergence of the given series. So this is all you will try to figure out from 1 to 8. based upon the comparison test. Now we move on to another test other than the comparison test. It is known as limit comparison test. Different from all the previous. We have gone through with the comparison test. Now we move on to another option known as the limit comparison test. Previously, we have basic comparison test. Now we are going to talk about limit comparison test. So surely we are going to observe some sort of limit behind the scene. So based upon the idea of limit, we will look into the convergence or divergence of the given series. So we have two series. I mean, we are interested to see the convergence or divergence of that series, but we generate another series with nth term to be labeled as Bn. Now that nth term is again to be obtained from the nth term of the given series, the same criterion that we developed. Take the highest degree term from the numerator, take the highest degree term from the denominator, and this is how you will generate the nth term of the second series. So we have been given this series with nth term An, and we will generate another series with nth term Bn. Both have to be positive term series. Every term should be positive. Only then we see that series is to be called as positive term series. So imagine behind the scene, both the one generated from the given series with nth term Bn and the given with nth term An, they are both positive term series. Then we look into the limiting value of this fraction, An upon Bn. So take the limiting value to this fraction. If the answer is non-zero, whatever the answer is there, positive value, negative value, but should be a finite real value. Shouldn't be infinity. So if the answer is finite real value other than zero, then both of the series will behave in the same way. Either both are convergent or both are divergent. So again, we are making a comparison, sort of comparison. So the first option is there. If the limiting value to this fraction is non-zero, finite real value, non-zero, then both of the series will behave in the same manner. If Bn converges, An converges, Bn diverges, An diverges. So since the convergence or divergence of this series would be known to us, most of the time it will be a P series. P series directly we can observe the convergence or divergence. So if it converges, we can directly say that with the help of limit comparison test, the given series is a convergent series, or the other way around. So the first option. If the limit is going to be non-zero, finite real value, but non-zero, what happens if the limit is zero? And on top of that, Bn converges. So limit non-zero, same behavior. Whether Bn converges or diverges, we also need to look into the convergence or divergence of An, whatever the option is there with Bn. But if the limit is zero, and on top of that, Bn converges, one option only, then An also converges. Third option, if the limit is undefined, infinity is there, and on top of that, Bn diverges, then we say that An also diverges. So convergence or divergence in the case if the limiting value is zero or infinity based upon one way, one option with Bn. Bn converges, An converges. Answer is infinity. On top of that, Bn diverges, An also diverges. So effectively, you have three options. Answer is 0. Answer is non-zero, finite real value, or infinity. If the answer is non-zero, finite real value, then whatever the option is there with Bn, An will be having the same option, convergence or divergence. So keep an eye on these options. So this test is known as limit comparison test. Again, we are going to make a sort of comparison between them, but it is going to be with the help of limit. Take the limit of that fraction An upon Bn and then see the outcome. Three possibilities are there: 0, one of the possibility, finite real value other than 0, or is going to be infinity. Take few examples from the exercise. So you can do it yourself. I give you an idea. So we are interested to see the convergence or divergence of that series. Number 9, example number 9, but by using limit comparison test. Restriction is it, we have to use limit comparison test. So series is given, that one, with nth term n minus 2 upon n cube minus n square plus 3. So we need to use a limit comparison test. So in order to make a comparison, there should be a second series. So how do you generate the nth term of the second series? From that nth term, take the highest degree term from the numerator, n, take the highest degree term from the denominator, n cube. So the fraction between n and n cube will return you 1 upon n square. So you need to compare this series with the one with nth term to be 1 upon n square. So there is going to be a hint over there also given to you. Compare this one with that series. So how do you generate this one? So the idea is that take the highest degree term from the numerator, from the denominator, simplify that one. It will result in the form of 1 upon n square. And what about 1 upon n square? It's a convergent P series because P is going to be greater than 1. So no, you have the answer to Bn. No, take the fraction between them, An upon Bn, and then figure out the limit. Figure out the limit. Take the fraction between this one and that one, and then figure out the limit. N approaches to infinity. You need to recall all the basic concepts in the previous classes, or we discussed at the start of this semester extensively. We discussed all sort of possibilities behind the scene to take into consideration the limit. Remember, with infinity, one of the option is there if you are encountered with indeterminate form. Infinity is there, infinity upon infinity, for example. So one of the option is there. You try to make the factors of the numerator and denominator and then see if the troublemaking factor is there, cancelled out. Or you see by dividing the numerator and denominator by the highest degree term as an alternative option. And the last option is to be L'Hopital's rule. L'Hopital's rule to be utilized. So these are the options behind the scene. If you are encountered with an indeterminate form, so then of course you need to figure out these options. So try to make the factors and see if the troublemaking factor is cancelled out. Divide the numerator and denominator by the highest degree term and then apply the limit, figure out the limiting value if it is finite. And still, if you have the indeterminate form, then the last hope is to use L'Hopital's rule. So this is all, you will look into that. Matter of finding limit only. And based upon the answer, take the fraction between this one. So the very first thing, to select second series. to whom you need to compare with that. So it will be obtained from the nth term of the given series. The idea is take the highest degree term from the numerator, from the denominator. So now you need to look into the limit of that fraction. An is the nth term to the given series. Bn, the one obtained from the nth term of the given series, now take the limiting value. And based upon the answer, fraction with this limiting value, finite field value, non-zero, 0 or infinity. So then, based upon the convergence or divergence of Bn, you will directly say An is to be convergent or divergent. So again, you see that the hint is given to you. N is there, N square is there in the denominator, 1 upon N under that radical sign. So this is how you will be having the second series. But if it is not there, and it is different from that, you need to make an expression in the numerator without that product form. Multiply them. N square would be the highest degree term from the numerator. N cube would be the highest degree term from the denominator. And this is how you will generate the nth term of the second series. So these are the bunch of examples you need to try by using limit comparison test. Now we have quite a few options to observe the convergence or divergence of a particular series. Because for the rest of the questions from 17 to 54, okay, you can try all these examples, but preferably you need to figure out up to, for example, 30, example up to 30. So from 17 to 30, there is no restriction upon the technique to be utilized. Whatever is appropriate to you, you are free to utilize that technique and then observe the convergence or divergence of the given series. So you see that from 17 to 54, there is no such restriction. As you see, in the case from 1 to 8, use the comparison test only. 9 to 16, use the limit comparison test only. Over here, there is no such restriction. So what are the options behind the scene? Plenty of options are there. Geometric series. Whether the given series is a geometric series, you need to figure out. And then based upon the common ratio, you will observe the convergence or divergence. The nth term divergence test is there. P series is there. Based upon the value of P, the most simplest case. Within a fraction of a second, you can figure out the convergence or divergence based upon the value of P. And then we have comparison tests. The basic comparison test is there. A limit comparison test is there. And the integral, Cauchy's integral test is there. So we have gone through with 3 different tests. Of course, those tests, they have different criterions. Integral test has got its own prerequisites that you need to figure out the corresponding f of x to be continuous, non-increasing, and based upon the limiting value to the integral, we figure out the convergence or divergence by using the Cauchy's integral test. Then we have the basic comparison, and now we have discussed the limit comparison. So quite a few options are there. So in other words, you can figure out, you can recall all those possibilities while trying to attempt those questions from 17 to 30. You are free to utilize any of those options behind the scene, whatever is convenient to you. So in the meanwhile, I take your attendance. Yeah, it's done. Yes, 24. 24. Do you want to say something? Okay, 177, please. You don't need to place your number over there because the attendance has been marked. Yes, 138.
यस सर सर ये अटेंडेंस के हवाले से पूछ रहा था कि LMS पे अटेंडेंस अपलोड हुआ है तो उसमें मेरा अटेंडेंस नहीं आया.
For what date?
ये सर before 2 days ago.
No, last attendance have not been updated yet. I mean, since we are taking online classes, the attendance has not been updated.
Okay, sir.
सर एक क्वेश्चन है.
Who is that person?
सर आपने कहा था कि कंपैरिजन टेस्ट के अंदर जो BN होगा वो AN कैन बी इक्वल और लेस देन BN. तो सर अगर हम BN को AN के बराबर रख दें तो कर सकते हैं?
No, it's a very technical. It's technical in a way. I mean, if you see, we say that n square plus 30 is going to be greater than or equal to n square for all sort of values of n. I see it. N square plus 30 is going to be greater than or equal to n square. I mean, do you see any finite value which make them equal to each other, like n is equal to 1, n is equal to 2, n is equal to 3, 4, 5? There is no such value to make them equal to each other. But since there is no other limit for n is there, so this is as a precautionary measure, we bring the equality sign